Electronic components and devices. Hello folks, welcome to this lecture on electronic components and devices. In this discussion, we will explore the fundamental components that form the backbone of electronics, understanding their characteristics, functionalities, and applications. This lecture is critical for anyone involved in electronics, whether designing, troubleshooting, or implementing electronic systems. Introduction to electronic components and devices, for example, resistors, capacitors, diodes. Resistors are one of the simplest, yet most essential components in electronic circuits. They offer resistance to the flow of electric current, allowing control over current levels within a circuit. Resistors are made from various materials such as carbon, metal oxide, and wire wound materials. They are characterized by their resistance value, measured in ohms omega, power rating, and tolerance. Characteristics: resistors come in different types, including fixed and variable resistors. Fixed resistors have a set resistance value, while variable resistors, such as potentiometers, can be adjusted to vary their resistance. Applications: resistors are used to limit current, divide voltages, bias active elements, and terminate transmission lines, among other uses. Capacitors store electrical energy temporarily in an electric field, acting somewhat like a small battery. They consist of two conductive plates separated by an insulating material called the dielectric. The ability of a capacitor to store charge is measured in farads F. Characteristics: capacitors are classified based on their dielectric materials such as ceramic, electrolytic, tantalum, and film capacitors. Key parameters include capacitance value, voltage rating, equivalent series resistance ESR, and tolerance. Applications: capacitors are used for energy storage, filtering, power conditioning, signal coupling and decoupling, and in timing applications. Diodes are semiconductor devices that allow current to flow in one direction only. They are composed of a p-n junction and are primarily used for rectification, converting AC to DC. Diodes have a forward voltage drop, typically around 0.7 volts for silicon diodes. Characteristics: different types of diodes include rectifier diodes, Zener diodes, Schottky diodes, and light-emitting diodes LEDs. Each type has its unique voltage and current ratings, switching speed, and intended application. Understanding component characteristics and applications. Applications: diodes are employed in power supplies, signal demodulation, voltage regulation, and as protection devices.
Inductors are passive components that store energy in a magnetic field when electrical current flows through them. They are usually made up of coils of wire and are characterized by their inductance, measured in Henry's H. Characteristics: inductors can be categorized as air core or iron core, with key specifications including inductance value, current rating, and quality factor Q. Applications: inductors are used in filtering, tuning circuits, transformers, and energy storage applications. Transistors are semiconductor devices used to amplify or switch electronic signals. They are the building blocks of modern electronic devices and are found in nearly every electronic product. Characteristics: transistors can be bipolar junction transistors BJTs or field effect transistors FETs. Key parameters include current gain beta for BJTs, threshold voltage for FETs, and maximum current and voltage ratings. Applications: transistors are used in amplification, switching, and signal modulation applications. Integrated circuits ICs. Integrated circuits are compact assemblies of electronic components packaged into a single chip. ICs range from simple logic gates to complex microprocessors that perform myriad functions in electronic devices. Characteristics: ICs can be analog or digital, and they are characterized by their functionality, power consumption, size, and processing capability. Applications: ICs find applications in computing, telecommunications, signal processing, and virtually all modern electronic systems. Sensors. Sensors detect and respond to environmental changes, converting physical parameters like temperature, pressure, and light into electrical signals for processing. Characteristics. Sensors can be active or passive, with key considerations being sensitivity, accuracy, response time, and range. Applications. Sensors are integral to automation systems, IoT devices, healthcare, automotive systems, and more. Here's a summary of an introduction to electronic components and devices. Resistors 1. Definition. A component that opposes the flow of current and reduces voltage. 2. Types. Fixed resistors, variable resistors, and thermistors. 3. Characteristics. Resistance R, power rating P, and tolerance %. 4. Applications. Voltage division, current limiting, and impedance matching. Capacitors 1. Definition. A component that stores energy in an electric field. 2. Types. Ceramic capacitors, electrolytic capacitors, and film capacitors. 3. Characteristics. Capacitance C, voltage rating V, and leakage current I. 4. Applications. Filtering, coupling, and energy storage.
Diodes 1. Definition: a component that allows current to flow in one direction but blocks it in the other. 2. Types: rectifier diodes, Zener diodes, and light-emitting diodes LEDs. 3. Characteristics: forward voltage VF, reverse voltage VR, and current rating I. 4. Applications: rectification, voltage regulation, and signal processing. Inductors 1. Definition: a component that stores energy in a magnetic field. 2. Types: air core inductors, iron core inductors, and ferrite core inductors. 3. Characteristics: inductance L, current rating I, and frequency response. 4. Applications: filtering, impedance matching, and energy storage. Transistors 1. Definition: a component that amplifies or switches electronic signals. 2. Types: bipolar junction transistors BJTs, field effect transistors FETs, and insulated gate bipolar transistors IGBTs. 3. Characteristics: current gain beta, voltage gain of, and power rating P. 4. Applications: amplification, switching, and logic operations. Thyristors 1. Definition: a component that controls the flow of current in a circuit. 2. Types: silicon-controlled rectifiers SCRS, triacs, and gate turn-off thyristors GTOs. 3. Characteristics: voltage rating V, current rating I, and gate trigger current IT. 4. Applications: power control, motor control, and lighting control. Integrated circuits ICs. 1. Definition: a component that contains multiple electronic components on a single chip of semiconductor material. 2. Types: analog ICs, digital ICs, and mixed signal ICs. 3. Characteristics: functionality, power consumption, and pin configuration. 4. Applications: amplification, processing, and control of electronic signals. Other components. 1. Transformers, components that transfer energy from one circuit to another through electromagnetic induction. 2. Relays, components that control the flow of current in a circuit using an electromagnetic coil. 3. Sensors, components that detect physical parameters such as temperature, pressure, and light. 4. Actuators, components that convert electronic signals into physical motion or action. Here's a summary of understanding component characteristics and applications of electronic components and devices. Electronic components. 1. Resistors oppose the flow of current measured in ohms omega. 2. Capacitors store energy in an electric field measured in farads F. 3. Inductors store energy in a magnetic field measured in henries H. 4. Diodes allow current to flow in one direction but block it in the other. 5. Transistors amplify or switch electronic signals. 6. Thyristors control the flow of current in a circuit. 7. Integrated circuits ICs contains multiple electronic components on a single chip of semiconductor material. Component characteristics. 1. Resistance, opposition to the flow of current, measured in ohms omega. 2. Capacitance, ability to store energy in an electric field, measured in farads F. 3. Inductance, ability to store energy in a magnetic field, measured in henries H. 4. Voltage rating, maximum voltage that a component can withstand, measured in volts V. 5. Current rating, maximum current that a component can handle, measured in amperes at 6. Power rating, maximum power that a component can dissipate, measured in watts W. 7. Frequency response, range of frequencies over which a component operates, measured in hertz. Component applications. 1. Filtering, components such as capacitors, inductors, and resistors are used to filter out unwanted frequencies or signals. 2. Amplification, components such as transistors, operational amplifiers, and transformers are used to amplify weak signals. 3. Voltage regulation, components such as voltage regulators, Zener diodes, and resistors are used to regulate voltage levels. 4. Current limiting, components such as resistors, inductors, and fuses are used to limit current flow. 5. Energy storage, components such as capacitors, batteries, and supercapacitors are used to store energy. 6. Switching, components such as transistors, thyristors, and relays are used to switch electronic signals on and off. 7. Sensing, components such as sensors, transducers, and detectors are used to detect physical parameters such as temperature, pressure, and light. Device applications. 1. Audio systems, electronic components and devices are used in audio systems to amplify, filter, and process sound signals. 2. Power supplies, electronic components and devices are used in power supplies to regulate voltage levels, limit current flow, and store energy. 3. Communication systems, electronic components and devices are used in communication systems to transmit, receive, and process information. 4. Control systems, electronic components and devices are used in control systems to monitor, control, and regulate physical parameters such as temperature, pressure, and flow rate. 5. Medical devices, electronic components and devices are used in medical devices to monitor, diagnose, and treat medical conditions. 6. Automotive systems, electronic components and devices are used in automotive systems to control, monitor, and regulate vehicle functions such as engine performance, transmission, and braking. 7. Industrial automation, electronic components and devices are used in industrial automation to control, monitor, and regulate industrial processes such as manufacturing, processing, and packaging. Component selection and interfacing. 1. Component selection, selecting the right electronic component or device for a specific application. 2. Component interfacing, interfacing electronic components and devices to form a circuit or system. 3. Component mounting, mounting electronic components and devices on a printed circuit board PCB or a breadboard. 4. Component protection, protecting electronic components and devices from damage such as using a fuse or a voltage regulator. 5. Component testing, testing electronic components and devices to ensure they are functioning correctly, such as using a multimeter or an oscilloscope. Component troubleshooting and maintenance. 1. Component failure, identifying electronic components or device failure, such as a blown fuse or a short-circuited component. 2. Component replacement, replacing faulty electronic components or devices with new ones. 3. Component repair, repairing electronic components or devices, such as repairing a damaged PCB or a faulty connector. 4. Component maintenance, maintaining electronic components and devices, such as cleaning or replacing components regularly. Conclusion: the world of electronic components and devices is vast and ever-evolving. Understanding these foundational components and their applications lays the groundwork for creating more complex and capable electronic systems. From tiny resistor chips to sophisticated integrated circuits, each component plays a vital role in modern technology. Thank you for joining this lesson on electrical components and devices. We hope to see you in the next lesson. Happy learning!